Hello dear students, welcome back to Learn Physics. In today's video, we are going to continue with the laws of motion chapter. Last class we discussed about the concurrent forces, equilibrium of concurrent forces which are acting on a coplanar plane. The coplanar forces, if it is if the forces are acting on in the same plane, then how we can find out the equilibrium of concurrent forces. Concurrent forces, if the forces are in a same plane, that is, if I am considering an xy plane, in that plane different forces are acting towards the same point, then I can say those forces are concurrent forces, and the net force acting on that system is equal to 0, then I can say that those forces are under equilibrium. Since it is acting on xy plane, I can write it as sigma fx is equal to 0 and sigma fy also will be equal to 0. Then the forces will be under equilibrium. Okay, so relating to this, we are going to do some numericals today. Okay, so first I'll take the numerical. First one here, this equation, this one we will do. Okay, the rod shown in figure has a mass of 2 kilogram and length 4 meter. Okay, in the equilibrium, find the hinge force acting on the rod and the tension in the string. So here it is marked, this is string. So the rod is this one. So this is the string which is acting. Through the string, usually tension will be acting through the string. And the mass of the rod is given as 2 kilogram and its length is given as 4 meter. Since it is under equilibrium, we need to find out the hinge force. That is the force which is acting at the hinge. So which are the forces acting at the hinge? We can mark it as here. This is the rod which is acting, weight W which is acting downward direction, and here through the string tension will be acting. This tension will be, this is at an angle 37 degree. It is given 37 degree. So these are the different forces, and here it is acting at this point, right? So here we will be getting a vertical force as well as a horizontal force. Here the horizontal force will be at the hinge force, horizontal force will be acting in this direction, vertical force will be acting in this direction. Okay, so two forces, hinge forces, horizontal and vertical. Now we are going to consider the value. W is acting downwards. If I am taking as G as 10 meter, yes, it's given. G as 10 meter per second square. So W I can take it as 20 Newton. 20 Newton is the W. So it will be the total length of the rod is 4 meter. So each from weight, each side is towards 2 meter. Both the sides are at 2 meter apart, right? Now we are going to consider the total tension which is acting. Tension is acting at through this direction, right? It can be divided into two components. Those components I'll mark it here. These are the two components which are acting. Here T cos 37 and this is T sin 37. So now we can move to the, so weight is W acting downwards, then upward direction T sin 37 which is acting upward direction. Next a vertical force which is acting in the upward direction. Vertical force which is acting vertical, we considered it as that also acting in the upward direction. W downward direction and vertical is acting upward direction. T sin 37 upward direction. Now we are going to consider the horizontal directions. When we are considering the horizontal direction, towards right, H is acting. Towards left, T cos 37 is acting the leftward side. So here two forces, H and T cos 37. These are the two forces. Since it is under equilibrium, the sum of all these and sum of all these will be equal to 0. So first I am considering the vertical direction. If I am considering the vertical direction, see, upward direction I am taking it as positive, t sine 37 plus v minus w equals 0. T is tension as we need to find out the force. T is not given. So T sine 37 is 3 by 5 it is given. So T into 3 by 5 plus V is V minus 20 equals 0. Next we are going to consider for the horizontal direction. Horizontally, here I can consider positive side h minus t cos 37. Cos 37 is given as 4 by 5. 4 by 5 equals 0. So we got the two equations. Here we need to find out the hinge force. So hinge force means horizontal component and vertical component we can find out here for the hinge force. Then find out the total hinge force. Here I'll tell you how to do. Now we can find out 3 by 5 it is means 0.6 t minus 20 equals v, and h minus 0.8 t equals 0. Okay, so it will be acting, whether it will be acting a clockwise torque or anti-clockwise torque. Here we considered only about the horizontal and vertical components, right? We didn't tell anything about the torque. What about the torque acting on it? W is acting downwards, so that can give a clockwise torque. And in which direction upward force is acting? T sine 37. That is the upward force which is acting. So that one will be giving you a what is that? Anti-clockwise torque. T sine 37 which is acting in the upward direction will be giving a anti-clockwise torque. Whether the rotation is acting over here, no rotation. That means this clockwise torque and anti-clockwise torque will be equal, right? So that is why it is cancelling each other. So we can consider the clockwise torque which is acting of 20 Newton, that will be equal to the anti-clockwise torque of T sine 37. Sine 37 we already got it as 0.6. So 0.60 I'll write down. So what is the clockwise torque? This is 20 into 2, because 2 meters only it is acting, right? So 2 meters, so 20 into 2, and from sine 37 also it is 2 meter. So we can write it as 20 into 2 equals, here I wrote it as clockwise, that one went upwards. 20 into 2 equals 0.6 into t. What is from hinge it is how much distance it is? 4 meter. From hinge it is 4 meter distance. This t sine 37 is acting in the t sine 37. From hinge it is 4 meter distance. From this weight is from 2 meter distance. Therefore it is 20 into 2, and this is 0.6 into 4 into 0.t. Okay, now we can find out t as 40 divided by 4 into 0.6. So this is the value of t. Okay, so 100 by 6 Newton. This will be the tension. Now we can find out the value of V and H. H equals 0.8 into 100 by 6. So here it will be 80 divided by 6, it is Newton. And V we can find it out, 0.6 into 100 by 6 minus 20. Yes, minus 20. So this will be the force which is vertical force which is acting on it. Okay, minus 10 we will be getting 10 Newton. Okay, vertical force and horizontal force. Now we got the tension, horizontal force and vertical force. But they didn't ask us to find out the horizontal force and vertical forces, right? Here we got the horizontal force as 80 by 6 Newton and vertical force as what is that, 10 Newton. So we can find out the resultant of these two. How can we find out the resultant? See, this is the resultant. So resultant force will be equal to root of a square plus b square plus 2ab cos theta. Therefore, F equals hinge force equals root of h square plus b square plus 2 cos 90 is 0. Therefore, root of 80 by 6 the whole square plus 10 square. Okay children, while you are solving, you will be getting this as 16.67 Newton you will get. Okay, clear? So this is how we will be solving this equation. Excuse me. So here I'll tell the whole question once more. Here we need to find out the hinge force which is acting at us. This is the rod and a string is there. So first we need to find out the forces which are acting at the hinges and through the rod, which and all forces acting. Okay, horizontal forces and vertical forces. Since they are under equilibrium, we can equate the horizontal forces to 0 and vertical forces to 0. We found out the clockwise torque and the anti-clockwise torque. Clockwise torque of 20 Newton. Clockwise torque is because weight is acting downwards, so it will be giving a clockwise torque. T sin 37 is acting upward, so that will be giving an anti-clockwise torque. Torque we equated, from that we got the value of T. And from T we can find out the H and V values. This is how we will be finding out the hinge force. So always remember, for finding out the hinge force, one of the methods is find out the horizontal component and vertical component, then find out the force. Clear children? This is how we will be solving this one. So next we are moving to the next question, that is here. This question I'll consider. So I'll give the next question over here. See, here the question is, a 50 kilogram homogeneous smooth sphere rests on 30-degree incline A and against the smooth vertical wall B. Calculate the contact forces at A and B. So here we need to find out the contact forces at A and B. See, first we can mark all the forces which are acting on it. Okay. So a homogeneous smooth sphere rests on the 30-degree incline at A. So this is inclined at an angle 30 degree at A. So here we know weight will be acting exactly downwards. And here, since it is resting at this position, a reactional force will be acting perpendicular to the plane. So it will be acting perpendicular. This is the reactional force. So normal reaction acting at the point A. Same way, from B also, perpendicular to that, a normal reaction will be acting from the point B. These are the forces, and don't forget about this 30 degree. We need to find out the contact forces at A and B, that is NA and NB. For that, the 30-degree angle, 50 kilogram is the sphere. Mass of the sphere is 50 kilogram. So what will be the force acting on it? See, here NA is acting like this. Okay. So if this contact force is acting exactly like this, I am dividing this into, so mg from the center, it is exactly acting downward direction. Okay, from here, this is the force which is acting through here. This, all the forces are passing through the center, right? So if this is making an angle 30 degree, then we can see that this also will be making an angle 30 degree. Okay, now you would have got an idea. This NA is with respect to this vertical, this is 30 degree. Okay, so this angle, here it is 30 degree, and here you can draw this. If you are drawing a straight line here, you will be getting an angle 30 degree, and from here you can write down the value 30 here. Okay, so NA, and this is NA cos 30, and here it will be NA sin 30. Okay, now we can equate NA cos 30. NA cos 30 is acting upward direction. This will be equal to the weight, that is equal to 50 into 110, that is equal to 500 Newton. Now what about NA sin 30? NA sin 30 will be balancing with NB. So NA will be equal to 500 divided by cos 30, that is root 3 by 2. So we will get it as 1000 divided by root 3 Newton as NA. And what about NB? NA sin 30. NA 1000 by root 3 sin 30 is 1 by 2. So it is 500 divided by root 3. Clear, children? This is we will be solving this one. So next, moving to the next question. One more question I can see here. From this, next question. This is the next question which is given here. A sphere of weight W equals 100 Newton is kept stationary on a rough inclined plane by a horizontal string AB. Okay, this is the horizontal string. So through the string, tension will be acting. Find tension in the string, force of friction on the sphere. So sphere, which direction friction will be acting. Okay, then force of friction on the sphere, normal reaction on the sphere by the plane. The normal reactional force also we need to find out. So tell me which and all forces will be acting from the center. It will be acting exactly. Weight will be downwards. Through the string, it is tension will be acting. Then frictional force will be acting in upward direction. This is the frictional force which is acting opposite. And perpendicular to this plane, normal reactional force will be acting. So these are the things we need to find out: normal reaction, tension and force of friction. Now, this angle is given as 30 degree. 30 degree angle also given. If this is 30 degree, this also will be equal to 30 degree. Okay, so I am redrawing it over here. W acting exactly downwards. Normal reaction, which will be making, in last class video I told you how to get this 30 degree. Okay, 30 degree here, and tension which is acting like this, and here it is acting a force F acting like this. Now we can find out all the components. N upward direction, N cos 30, leftwards, that is N sin 30. Right side direction, tension, and we can divide this frictional force also as F. Friction is making an angle 30 degree. So here it will be F cos 30, and upward direction F sin 30. So all the horizontal and vertical we can consider. And W is acting downwards. First I am considering the vertical one. N cos 30 plus F sin 30 equals W. Weight is 100 Newton. 500 was the previous one. Then next one is minus N sin 30 plus F sin 30 plus T. N sin 30, this is tension which is acting in this direction. So plus T minus plus F cos 30. So this is equal to 0. This is under equilibrium. So it is, all these forces will be equal to 0. Next we can solve this. Here n cos 30 plus f sin 30 equals 100. And what about the torque acting on the system? Next we can consider the torque. Torque is equal to net torque acting on the system is equal to 0. So here which and all forces. So for considering the torque acting on the system, see here tension which is acting here. So from here the radius is given as, what is the distance which is tension into radius. And what about the frictional force which is acting from the center till here? The frictional forces again, frictional forces acting as at a distance r. So we are getting it as T equals F. So here we consider the net momentum, that is net torque acting on the system is equal to 0. So from here tension is acting like this and friction is acting like this, frictional force. So here we need to consider the T into R equals F into R, upward momentum and downward momentum we consider, clockwise and anti-clockwise we consider. So T equals F we got. So in these two equations we can substitute it as T equals F. So n cos 30 plus F sin 30 equals 100. Next one, minus n sin 30 plus F cos 30 equals 0. Now solving this, cos 30 is root 3 by 2, sin 30 is 1 by 2 equals 100, and minus n sin 30. Sin 30 is minus n by 2 plus f cos 30 is root 3 by 2. F root 3 by 2 equals 0. So when we are solving this, we will be getting the value of F and n. Final answer you can check. N equals 100 Newton you will be getting, and F you will be getting it as 26.8 Newton. So since T equals F, we can write down F T also same value, 26.8 Newton. So these are some of the numericals from the equilibrium position. How? For the equilibrium of concurrent coplanar forces. Clear children? So I hope today's video is a bit lengthy I guess. Then also 3 numericals we did. Please go through these numericals, it will be useful for you. And please don't forget, if you like the channel, please don't forget to subscribe, like and share. Okay dears, that's all. Thank you.